On this problem, we're asked to use the ratio test to determine if the series converges. Okay, so we've got the ratio test rules written over here. It says that you take the limit as k approaches infinity of a sub k plus 1 divided by a sub k, and if r turns out to be between 0 and 1, including 0, the series converges. If r is greater than 1, the series diverges, and if we get r is equal to 1, the test is inconclusive. Okay, so here's how we're going to go about doing this problem. Let's take the limit as k approaches infinity. We're going to write this, except everywhere we see a k, we're going to put a k plus 1 in its place. Okay, so it's 3, and instead of k factorial, I'll have k plus 1 factorial, and let me make sure I put another parenthesis so that can get squared, divided by 10, and instead of 2k, we'll have 2 times k plus 1. Okay, so I'll replace the k with a k plus 1. And then on bottom, we'll put this, because it says just a sub k, so we can just write that. So 3 times k factorial squared divided by 10 times 2k factorial. Okay, so I'm going to do two things in the next step. I'm going to take the fraction that's down here, and I'm going to flip it up and multiply it times this. And I'm also going to clean some stuff up inside of these parentheses. Okay, so we have the limit as k approaches infinity. Okay, so let's start cleaning it up. K plus 1 factorial is the same as k factorial times k plus 1. It's one extra term. So instead of k factorial, we get one extra term. So I can write this like this. 3 times k factorial squared, because of this, and then times k plus 1 squared, because of this. Okay, so k plus 1 factorial is the same as k factorial times k plus 1. But they're also being squared in this problem. Okay, and then on bottom we have 10. Okay, and I'm going to write 2k factorial out front, because this is going to get distributed and become 2k plus 2. So there's going to be two extra terms. Okay, so I'm going to first have 2k factorial, and then my first extra term is 2k plus 1, and my next extra term is I erased the 1 there, 2k plus 2. Okay, 2k plus 1, 2k plus 2, and 2k. Okay, these three things combined is the same thing as 2 times k plus 1 factorial. Okay, now like I said, I'm going to take this bottom fraction, I'm going to flip it up and multiply, so let's put a big multiply sign there. Now I'll put the 10 times the 2k factorial in the numerator, and in the denominator, 3 times k factorial squared. Okay, now you'll see why I did this work in splitting out some of these things. Okay, so now we can say, okay, well, I have a 10 and a 10. I can cross those out. A 3 down here and a 3 up here. I can cross those out. Okay, I have a k factorial squared, and I have a k factorial squared, and I have a 2k factorial, and I have a 2k factorial. Okay, so all that stuff gets canceled. So let's write down what we have left. Okay, so in the numerator, this is the only term that hasn't been canceled. So it's k plus 1 squared. I'm going to write it out as k plus 1 times k plus 1, which is the same thing as k plus 1 squared. And on bottom, I'm going to do a little work on that too. You see this term 2k plus 2? If I factor a 2 out of both of these, divide that by 2, it becomes k. Divide that by 2, it becomes 1. So if I factor a 2 out, it becomes k plus 1, which is going to be useful for us in the next step. Okay, so I'm going to factor out a 2 and make that term k plus 1. That takes care of this term. And now I'll write this term down here, which is 2k plus 1. Okay, how did that help us? Well, you probably see it already. We can cancel again. So that's nice. Okay, so we end up getting the limit as k approaches infinity of k plus 1 divided by 2 times 2k plus 1. which if you took it one more step, you could probably already see the answer if you're up on limits, but let me point it out to you just in case. So k plus 1, if I distribute this, it becomes 4k plus 2. Now, when you take the limit of a rational function and the top and the bottom have equal powers, k to the 1 power and k to the 1 power, then the constants in front of that are your answer. So the constant in front of this top k is a 1, since there's not a number, and then a 4 on bottom. So the answer to this limit becomes 1 over 4. Okay. That being the case, we go back up here to our rules and we say, okay, it looks like it's this one because a fourth is between 0 and 1. It says if you get an answer that's between 0 and 1, then you can say the series converges. So we can say it converges. And that's it.